Hi everyone, it's Sorkin. Today we have a problem when we are given an input string and also a dictionary, and we need to find out whether or not we can split that word into the words that is in the dictionary. For example, in this case we have apple and apple, pen, apple, so we can split that to apple, we can split that to again to apple, and we can split that to pen, which is in our dictionary. And by the requirement, we can use the same word can be used multiple times. We are going to use this problem using dynamic programming and specifically bottom-up approach. So what's the idea behind bottom-up approach? The idea is that we are taking a problem and splitting that problem into subproblems, and then we are solving first subproblem that builds up to our solution. So for example, in our case, let's say we have input string as apple and we are creating an array of integer dp where we are storing our subproblems that we already solved. So when we initialize, we set all the values to false, right? Because we haven't solved anything. Only the first value we are setting to true. I'm going to explain in a minute why. So what are the steps that we are using here? The first step is that we have an I pointer, right? We are going over our string, and at each step we are checking our string, the substring that we have, we are checking against our word. Is that equal to our word or not? So the first one is that in order to check each word, in order to check the I, for example, in the first, our substring is, our I is equals to 1, right? Our substring is A, so the next one is P, right? A, P at this point. So in order to check that against each word, at least it should be more than that word, right? Let's say that if I is less than the word that we are checking, then in that case, we are skipping that because we cannot check that the size of the word is less than, size of the substring is less than the size of the word. So that's our first step. What's our next step? Let's say that we are at this point, right? We are at this point as I equals to 3 and we have app, so we are checking against the first word and. So it's less than, more than or equal, right? So more than or equal to word length. And the next one, what we are checking here, we are checking that if the, let's say that we had some other words earlier, right? So in order to consider this one, this app, right? So we need to also the words that is we already should solve the problem that come before it. So in our case, so I is minus word length, so it equals to this value, right? So this value is, so by default we are setting specifically for this case, so it's true, so we are passing to the last one, to our last check. What is our last check? Last check is that we are checking against our word. So basically we are taking the I minus word length, so which means that the I minus word length, which means that the starting from the first index to third index, which means that our substring app, if the app is equals to and. No, it does not equal, so we are keeping this value as false. Now we are going to the next one. I is here, the same, it will be false. The next one, I is equals to apple. So let's say that we have checked for this word, it's still false, and now we are checking for apple. So we're checking for apple. Does it pass our first step? Yes. Does it pass the I minus word length? So this value, right, from here, it is true, so it passes. How about the last one? Last one is that we are again checking that the I minus word length from here to I, so this substring, right? Does it equal to our word? Yes, it equals to apple, so we are setting this value to true. So at this point we have solved this subproblem. So until our index is equals to 5, we have one word, right, which is equals to our word in the dictionary. Now we are moving our I pointer here. Again, we are checking apple A, right? We are checking apple A, this substring. Then we are going to the next pointer. It still returns as false, so it doesn't pass these steps. We are going to the next one, which is apple and apple n, so it still returns as false. We are keeping this value as false. Now let's go to our last step. So in our last step, we are checking and, right? So the first one is that we are checking I is more than word length. Yes, it is. Then what is the next one? Next one is I minus word length. Let's say we are checking against and, right? We are checking against and. So I minus word length, so which means that the length of the and we are checking here, does this value true? Yes. So we have solved this subproblem earlier, right? We have solved this subproblem and the value of it true. So it means that now we are going to the last step to check that if it is really our word or not. Now we are checking I minus word length, so which means that starting from here to here, to I, right? We are checking is and equals to and. Yes, it equals. So it means that at this point, we are setting our DPI here to true. So we are setting here to true and here, right? Earlier we set that to true. And that's it. So at the end, when we are returning the value, whether or not we can split, we are just returning DP, whatever the word, whatever the string length minus 1 is. So the last value will be the value, will be the whether or not we can split this problem, split this word into the words that is in our dictionary. Again, to wrap up, for this problem, we have split that into sub-problems. First, for example, here, right? We have solved the sub-problem that helped us to build up to our solution here. Okay, first thing that we do here, we are creating an array of Boolean where we are storing our sub-problems. We are setting the DP value 0 for the true that we are using later on. And then we are going over our array for the I starting from 1 to 3 and so on. So we are checking for each case when I is equals to 1, 2, 3 and so on. We are checking against each word. And we are checking three rules that we have mentioned earlier. First, that if the I is more than the word length, right? If we are passing this one, the next one is that have we solved earlier problem that comes to that until that word, right? Let's say that the word is and apple and, so we are checking the last index. So we are checking and we need to check also have apple also exist in our dictionary or not. At that point we already solved that. So we need to also check that here. And the last one is that we are checking that actually that word is equals to, that substring is equals to the word. If that is, then we are setting that to true and that there is no necessity to progress further, so we are breaking that. And the last one, we are just returning the value of the DP string length. So that will be the value of that would show whether or not we can split that word into the words that is in our dictionary. Okay, what's the time complexity of this solution? The time complexity is n multiplied by L. So these 4 loops, right? This is n is the length of our string, and the L is the average, and is the average size of the word. So and about the space complexity is determined by this data structure that we are using here, an array of DP, which is the size of our string, and it's of n. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.